we've said earlier, we are now in the experience economy. And a key part of that is the quality of consumer connectivity. And the market leader in secure connectivity solutions for embedded applications is NXP. So let's watch a video about this company, NXP. Great video. So now, please join me in welcoming to the stage NXP's Senior Vice President of Product and Technology Enablement, Chris Collins. Chris, welcome.
Thank you. Bonjour and good morning. I think that video is probably about as good as it's going to get. It's going to go downhill from here. I work for NXP. My name's Chris Collins. I'm a Senior Vice President. I manage about 1,000 really brilliant and fantastic engineers around the world that bring technologies and products to life. One of our focuses is driving scale and actually digital transformation. And last night, I had a really nice dinner. Thank you, Bernard. I met a lot of amazing people. I met people trying to revitalize and commercialize supersonic flight, building amazing airplanes. I met people building amazing commercial jets. I met people building the most efficient air conditioning and heating systems. And I met people printing 3D parts of body parts. So I could only imagine the plastic surgery TAM for 3D body parts. And then I thought about myself, and I thought, wow, I don't have anything that'll fill up this room. You know, the things that NXP makes are about this big, okay? And they're easy to lose. And in these, you can have hundreds of millions of components. So this in itself is a whole engineering supply chain, not just manufacturing it after design. And that's what I'm going to talk to you about today. Does anybody know what NXP stands for? That's what I thought. Okay, it stands for Customer's Next Experience, right? And that's what the founders decided to call it. So it's actually a privilege to be able to share with you our next experience of our digital transformation journey down the 3D realm. So probably what I'm going to show you today is not really that exciting, because I think most people in this room have done this before. You're used to PLM. Well, I'm from Semiconductor. When I was a kid, I used to watch Sesame Street. And there's a song called One of These Things, and they say, which one of these things is not like the other? And they repeat that in the song, and that's Semiconductor. You know, all these great products that Dean showed and Accenture showed, and our products are in there, but they're made differently. And for Semiconductor being such a high-tech business, there's really a lot of low-tech capability in there when it comes to creating a product. So I'm going to show you kind of what we've been through the last year and a half. All right, so a little bit about NXP. We're in 30 plus countries, about 9.4 billion in revenue. We have 9,000 patent families, over 9,000 engineers, close to 10,000 engineers. So a third of our workforce is R&D. And we have a 60-plus year history. Those of you in Europe might remember NXP came from Philips, and Freescale came from Motorola, and NXP and Freescale got together. So in 60-plus year history, there's a lot of knowledge, which is also a barrier to change. Okay? So it is really difficult, as Ms. Chang mentioned. Culture is really an issue when it comes to driving a digital transformation. Okay, our target markets: automotive, industrial, IoT, mobile, communication infrastructure. There's a Capital One commercial where Jennifer Garner, it's a credit card company, and Jennifer Garner gets on TV and she says, "What's in your wallet?" Everybody recognize that commercial? Okay. Well, that's one of the products we make. So this little silver piece on your credit card here, that's actually not the chip. That's a contact. The chip is actually embedded in the plastic. Okay. So next time you see that Jennifer Garner commercial and they say, "What's in your wallet?" you can shout out NXP and your family will look at you really crazy. Okay. Across those markets, when it comes to focusing on safety, security, mobility, we pretty much entertain all product spaces from the cloud infrastructure, some of those things you saw from Amazon, and edge to node. And these products you use every day, and you use NXP products every day. You just don't know it if you have a mobile phone. We're one of the co-creators of near-field communication along with Sony back in about 2002. So when you hold up your phone to make a payment, you can thank NXP doing the secure chip that does the transmission there. So I'm in your wallet, you just don't know it. Okay, so let's talk about sustainability. So from a sustainability perspective, we really view a key foundation for that as total quality. Okay, so first time right development and designs. That means you have to have good servant leaders in R&D that learn from their mistakes and have foresight on what to do next. We have a zero defect methodology and functional safety methodology, and automotive requirements now have moved from parts per million to parts per billion. Okay, so Audi, Conti, none of these people want to see a 0-kilometer fail of a product. I mean, if you're making all these cars and there's a product failure and the car doesn't run before it's delivered to the customer, well, if you make about 6,000 cars a day and you have 1% 0-kilometer fails, where do you store 60 cars a day? So it's a really big deal for the automotive companies. And then we're seeing even some high-performance consumer companies, such as in the mobile space, pushing us hard for zero defects. And you have to have really flawless customer support. Right? So we looked at Dassault systems to help us in our vision of total quality and sustainability. You'll see over 40 billion plus intelligent devices shipped in 2020. Okay, so if you're going to connect 40 billion plus devices in a supply chain, then you do need total quality and you need to share data. Okay, so that's really the digital transformation for us, is how we share our data from an inherently insular industry, semiconductor, to now sharing our data in more real time with our customers. Okay, so what were our requirements for our, what we'll call our enterprise design product data management system? And I'll show you some statistics here in a minute. We have 75 plus design sites across the globe. Of course, I mentioned the zero defect methodology. We have huge, complex design bill of materials. So in this little thing, which are easy to lose by just dropping them on the floor, like I said, we'll have 5,000 components in there. Well, one component might have 100,000 elements in it: resistors, capacitors, transistors. So now you're talking about keeping track of a lot of things from a lot of different places, from a lot of different groups around the world. And they get pretty huge and complex, and then you miss things and cause revisions, and then you have fails in the field. Okay? We wanted enterprise-level defect visibility and tracking. I think this is very novel for what we've been able to do with Dassault systems. Traditionally, people look at just the supply chain, the manufacturing piece, and where you get all the components and so forth. We use Innovia in that realm, but now we're also innovating in the design R&D space and using it for how we do all of our semiconductor chips. Right? End-to-end traceability, I can find a transistor defect on any piece of silicon from any fab. Doesn't matter if there's a billion transistors with this system, and we can find it quickly. We have a global IP distribution and reuse program. Everybody does IP reuse. The difference is how good you are at it. Okay? I think this enables us to be more than best in class, and we have stringent security requirements. Okay, if I'm going to be in your wallet, I just can't have anybody work on those chips. They have to be high secure restricted environments, and they use tools from non-restricted and non-restrictive environments, and then getting those two to talk to each other in a secure way is key, and we can do that with Innovia. Okay, and lastly, I heard Ms. Chang mention this too, single source of truth. That's very difficult to find in a semiconductor company. Okay, as I mentioned, from an IP standpoint, there are some suppliers out there, semiconductor suppliers, that don't know how much IP they have or what they have, and they have to pay consultants to come in and scour their system and tell them what they have and where it is. Right? So it's very difficult, if impossible, for them to have a single source of truth. And if we're going to have ultimate total quality and traceability, a single source of truth is the only way to make sustainability. Okay, trusted partner. I'm going to give a shout out to a few folks here. I don't know how many people are in here from Dassault Systems, but they worked with us since 2016, and they unseated what I would say is really just a vendor. And they assembled, I think thanks to Bernard's culture he's instituted, a really thoughtful, energetic, innovative team that could recognize the vision behind what could be done in semiconductor one day. Right? So Dassault Systems was selected. They unseated a supplier. I won't say who they are, but they're just located in Redwood City. I'll leave it at that. There's a strong semiconductor focus in Dassault Systems. They were a trusted advisor. They even brought in one of their third-party partners, Consensia, really fantastic company that all three of us worked together to get this solution put out. And of course, it's anchored by Innovia. Right? Okay, I mentioned before complexity in bill of materials. So on the left here is a digital networking chip called Layerscape. This thing is going to have 1,600 pins on it. So that little credit card I just showed you had 4, 3, 5 pins on it. This will have 1,600 pins on this chip, and it's going to be a little bit bigger than what I showed you. But this is very complex with millions and millions and hundreds of millions of transistors. Okay? And then our I.MX8 microcontrollers, you use all those. If you go drive a car nowadays, at least one not from the 60s, it probably has at least a dozen NXP microcontrollers in it, controlling your windows, controlling all sorts of things. All right, so here's just a high-level overview of what we put together. All right, so we have Design Sync for a lot of our IP data. Our IP teams all release and publish. I'll show you some statistics here in a minute. All the chip errata, the test management, the system in package, bill of materials. So sometimes we'll take 2, 3, or 4 chips and stitch them together with wires thinner than a human hair, and then we'll encapsulate that whole thing in a piece of plastic, and it's still as big as your pinky nail. And then we have chip teams that do all their IP versioning and tagging methodology. Right? So introducing tagging methodology to people that were in a very non-structured way of doing design it takes a while. Okay, and all that, of course, was anchored by Innovia, and I'll share some statistics with you now. Okay, so we have almost 10,000 engineers, and almost half of them in 1 year using this system. Okay, we have 1,400 daily distinct users per day. Not everybody needs to use the system daily. Some might use it once a week. Some might use it once every 2 weeks. We have 55 design sites around the globe that are using this. We have 2,500 IP tickets worked per month, 2,300 IP releases per month. So there is where it's hard to keep track of things if you're reusing IP, because this stuff, much like software, is constantly being updated, and those different what we'll call bombs that are fixed on the system, you want different people to be able to access them at different times and different life cycles of each of those bombs. So it gets very difficult, if not impossible, to keep up with that if you don't have a system like this from in your design world. And then, like I said, we had 5,000 plus component engineering bombs. And most of the groups, especially in semiconductor, it's a lot of cobbling together of previous companies. So you heard NXP and Freescale, well, they were on 2 different systems. One wasn't on a system, one was on a system, and then you buy a 60-person design team, and they're doing something else, and you just keep adding and adding and adding, and as we've been able to acquire companies, and we have acquired several small little companies, they can just walk right into this system and start doing design, even with their previous IP. So all of NXP's IP is loaded into this system, and we even take it one step further, and that my team puts out all of what I'll call, let's call it Legos. Everybody knows what a Lego is, right? Maybe you remember when you were a kid, you had those Lincoln logs, and you had different sized logs and a roof, and so that's my group. We put out all the Legos. Okay? And there's all different kinds of Legos, and there's hundreds, if not thousands of them, and the designers can take those and make a house or a car or whatever it is they want to make out of it, and then they can make their own Legos. So we're actually distributing all of our process design kits, the whole tool set. Everything is distributed as part of the BOM in Innovia, and I'm not aware of anyone doing that, and it provides us ultimate traceability and affordability. All right, next slide here. Okay, so I'll just finish with this, right? So it's truly inspiring to work at a company that focuses on safety and security. And I'm not talking about just secure from hackers, but we make a lot of chips that go in products that make people's homes safe and so forth. And so NXP's real focus is all about safety, security, and connectivity. And on this slide, you can see some of the things that we're in. And now if you take a look, now you really know you use a lot of NXP products. Right? Wherever you are in the world, you use a lot of NXP products, and my only hope is they are contributing to a safer and secure environment for you. And I'll just close with asking you, don't forget who's in your wallet, NXP. Thank you.